We're going to find the derivative of the tangent curve. First of all, I have a unit circle, and I have a point xy on the circle. It's x units over and y units up, and the hypotenuse is 1. Okay, so for tangent of the angle, it is opposite over adjacent. And the opposite is y, and the adjacent is x. But we also know that x over 1 is adjacent over hypotenuse, which is cosine. And y over 1 is the sine of the angle. And therefore, y is sine, and x is cos. So the tangent is the same as sine over cos. But we also know by Pythagoras, we also know that the square on the hypotenuse is equal to the sum of the squares on the legs. So if I square x, I get y squared. If I square y, I get sine squared. Okay, and so that equals 1. So therefore, this is like a Pythagorean identity. Cos squared plus sine squared is always 1. Okay, now we have to do this question. So let's take the derivative of tangent, which is the same as the derivative of sine x theta over cos theta. Okay, x or theta, same thing. Now, we're going to use the quotient rule. Square the denominator, the derivative of the denominator. Now, the derivative of the numerator minus the numerator. So far, so good. So the derivative just goes like this. The cos of theta, the derivative of sine is cos. We did that yesterday. And over here, minus sine. The derivative of cos is minus sine. So, and that's all over cos squared theta. Okay, so this now looks like cos times cos is cos squared theta. Negative and the negative is positive. Sine times sine is sine squared theta. That's all over cos squared theta. But cos squared theta plus sine squared theta is 1. Cos squared theta plus sine squared theta is 1. And that's equal to that. But 1 over cosine is secant. Therefore, the derivative of tangent is sec squared theta.